we have already learned about how to multiply with radicals. The last few videos have been about that. So what we haven't seen yet is distribution, because distribution is a form of multiplication. So let's see a few different scenarios where we have to distribute with radicals. Okay. So let's multiply the square root of 5 times 11 minus radical 2. Okay, so we know we have this single term on the outside, and we have to distribute it to both terms on the inside, right? We have two terms on the inside, the 11 and the radical 2. So we're going to distribute this radical 5 to both of those. And what's going to happen is we'll multiply these. Now, when we do that, the whole number, the coefficient, we always put that out front, and then we put the radical 5 after it. We can't multiply 11 times radical 5 because it's not inside a radical. So we just write it like this. Minus, here, these are both inside the radicals. So we would multiply those numbers and just rewrite that as radical 10. And we also look at both of them and say, can we simplify them at all? And the answer is no. There's no perfect square as a fact that's a factor of 5 or 10. And we haven't talked yet about adding and subtracting radicals, but you can't add them if these numbers inside are different. So that's all that we're going to be able to do. That is it. Next, radical 6 times, let's go, 5 radical 7 minus radical 6. So again, we have a single term out front, two terms inside. So we'll distribute radical 6 times 5 radical 7. So what's happening there? We have a coefficient. That's just going to stay out front. We have the 6 times the 7. We're going to multiply those. 42. Minus, well, here we have radical 6 times radical 6, which is radical 36. Then we look to see, can we simplify either of these? 42. You look at that and you think, maybe I can break that up into two numbers where one is a perfect square, but you can't. There's no perfect square factor of 42. So we just have to leave that as it is. But we can take the square root of 36. It's just the whole number 6. And so that's all we got. That is it. That is multiplied, and it has been simplified. Another thing that we can do with distribution is work with binomials. We can look at something like this. Let's go square root of 6 plus the square root of 2 times the square root of 5 plus the square root of 2. So you can have to do, you might think of it as FOIL, you might think of it as binomial distribution, but both of these terms have to be distributed to both of these terms. So let's work through this. Radical 6 times radical 5. That is going to be radical 30. Radical 6 times radical 2 is plus radical 12. Then we go to this one. Radical 2 times radical 5 is radical 10, and this was plus, so we'll carry this over as radical 10. And then radical 2 times radical 2, plus and plus, means it's plus radical 4. And then we look to see if we can simplify any of these. 30 has no factor that's a perfect square, so it has to stay radical 30. Plus, well, 12 can be written as 4 times 2. I'm sorry, 4 times 3. 4 is a perfect square, so we can take its square root and pull it out front as 2, and the 3 stays in. 2 radical 3. Plus, 10 has no way to simplify it, So we leave it as radical 10. And then the square root of 4 is 2. So we can simplify that just as 2. Now, again, none of these radicands are like, none of them are the same. So this is actually as much as we can do to simplify that expression. Let's look at one more, and I really like this one. This is kind of a fun one. So let's do the square root of 3 plus the square root of 2 in parentheses, so grouped, times the quantity radical 3 minus radical 2. So take a look at that and try this one on your own. See if you can even predict before doing the multiplication what might happen. And then go ahead and do it. I'll keep going. So the first thing we'll do is do radical 3, distribute that to radical 3, which is radical 9. And then we'll do radical 3 times radical 2, but it's minus, so it's minus radical 6. Then we'll go to this square root of 2, distribute that to the 3, it's a plus, so it's plus radical 2 times 3 is 6. And radical 2 times radical 2, one's plus, one's minus, minus radical 4. So let's do a little simplification here. The square root of 9, we can do that. It's just the number 3, so the radical's gone. Here, what do you notice? They are identical terms, square root of 6, square root of 6, one's minus, one's plus. Whenever we have two opposite terms that we're combining, and one minus, one plus, it's always going to be 0, right? These condense to 0. So the terms basically just sort of vanish when it comes to this moving forward with this expression. But over here we have minus radical 4, which is the same thing as minus 2. Minus 2. If you prefer to write condensing this to plus or minus 0 and then do the minus 2 for this one, that's fine. Anyway, 3 plus 0 minus 2 is just equal to 1. So this entire thing just simplifies to 1 because 2 of our radicals were of a perfect square and the other 2 just canceled out. So that is how we distribute with radicals.